Today we're going to solve two-step equations. So two-step equations obviously build on solving one-step equations. So if you need to, please go back and watch the video on solving one-step equations. So with two-step equations, first we want to isolate the term that has the variable in it and then solve for that variable completely or get it alone completely. So for example, the most basic two-step equation we could have is just an integer times a variable. So let's say we have 3x, and then we add or subtract a number, minus 7 equals 2. So I always like to draw a line through my equal sign because that separates our two sides. Because remember, when we're solving an equation, whatever operation we do to one side, we must do to the other to keep it balanced. So right now, we want to isolate the 3x. That's the term that has our variable in it. Isolate means to get it alone. So in order to get 3x alone, we want to add 7 to both sides. That gets it alone, so we have 3x equals 9. And now if you look at that, now it's a one-step equation. So we have 3 being multiplied to x, so we divide both sides by 3. The 3's cancel over here, x equals 3. You want to check this, plug that 3 back in. 3 times 3 is 9. 9 minus 7 is 2, so it checks out. All right, so we have negative 6 equals negative 22 minus 4x. So I want to solve for x. So I draw my line through the equal sign. Over here is our variable, so negative 4x is the term that has our variable in it. So first I want to isolate that negative 4x by adding 22 to both sides. So cancel off over here. Because we're adding a positive and negative, we subtract. 22 minus 6 is 16. And make it a positive 16 because a positive 22. That's the larger number. So 16 equals negative 4x. And now we can isolate the variable completely. So in order to get x by itself completely, negative 4 is being multiplied to x, so we divide both sides by negative 4. Negative 16 divided by negative 4 is negative 4. And that's the answer for x. Okay? You could plug it in over here if you want to check it. Negative 4 times negative 4 would be positive 16. Negative 22 plus 16 would be negative 6. So it does check out as well. So in this example, we have x divided by 2 minus 7 equals negative 13. So the fraction is the term that has our variable in it. X is being divided by 2. So we want to isolate that term by adding 7 to both sides. We're doing the inverse operation of subtracting 7. So we bring down the x divided by 2, because these cancel to give us an answer of 0, right? And then negative 13 plus 7 is negative 6. Subtract and keep the sign of the bigger number. For our last step, now we can isolate x completely. Since x is being divided by 2, we want to multiply both sides by 2. So x equals, these cancel over here. Multiplying and dividing by 2 are inverse operations. So we're left with 1x. And then negative 6 times 2 is negative 12. If you want to check it, plug it back in right here. You can always check these. Negative 12 divided by 2 is negative 6. And negative 6 minus 7 does in fact give us negative 13. So it does check out as well. For our next example, we have x minus 5 divided by negative 3. And that equals 4. So I'll draw a line through the equal sign. Now, if you look at this problem compared to the last problem, in this last problem, only the x was being divided by 2. In this problem, it's x minus 5 being divided by negative 3. So it's like a quantity being divided by negative 3, or these are both being divided by negative 3. So we have to get rid of this negative 3 first because it's being divided into both terms. So we want to actually multiply both sides by negative 3 first. And hopefully you see the difference between this problem and the last problem. So since these are inverse operations, they cancel. X minus 5, and now 4 times negative 3 is negative 12. And now we have an easy one-step equation to solve. Since 5 is being taken away from x, we could add 5 to both sides. X equals negative 7. If we want to check this answer, plug negative 7 right there. Negative 7 minus 5 would be negative 12. Negative 12 divided by negative 3 is positive 4, so it checks out. Okay, so here we have a fraction times a variable equals a number. So Most people would consider this a one-step equation, but depending upon the way you do it, it could also be two steps. So that's why I put it into this lesson. So there's many ways to do this problem. Probably the easiest way for many students is a two-step equation. So for example, we have 7/8 times x, but if we want to get rid of the denominator here, which is 8, we could multiply both sides by 8, right? So these cancel. We have 7x, and then negative 14 times 8. We can do some work off to the side here, or use our calculator, right? And we get 112. So this is a negative 112. Last step would be to divide by 7. Again, you could use your calculator or do some side work. And I'm just doing the work here. 42 goes into, or 7 goes into 42, excuse me, 6 times. No remainder. So we get an answer here of negative 16. Okay, so the way I just did it for you was two steps. So if you have a fraction times a variable, one way to do it would be you could multiply both sides by the denominator of that fraction, and now you have a one-step equation after that. Okay? But now let's look at that equation a different way, because it never hurts to do a fraction times a variable. That's a problem sometimes students struggle with. All right. So the other way we could do that problem, we could times both sides by the reciprocal, because that would get rid of everything at once. So we can multiply both sides by 8/7, right? Because then these cancel and these cancel in terms of being left with 1x. Remember, whatever we do to one side, we do to the other. And now we're left with x. So you could say this is one step. And now you're multiplying fractions over here. And we can reduce diagonally. So we get 7 goes into 7 once. 7 goes into 14 twice. Now we can multiply straight across, right? We get 16 over 1, which is just 16. But now I'll double check my sign. It's a negative times a positive, so it's a negative 16. So notice we got the same answer, just did the problem a different way. And just so you're aware, you could also divide both sides by 7/8 at the first step, but then ultimately you're still going to end up doing this because when you're dividing by a fraction, you flip the second fraction and make it multiplication. So again, I wanted to throw this problem in there for two reasons. One, because students always struggle with fractions, and two, because depending upon the way you do it, it could be a one-step or a two-step equation. Finally, our last one here, negative 11 equals negative x plus 3. So we got to solve for x. Now remember, if you don't see a coefficient in front of x, it's a 1. So there's like a negative 1 there if that helps you if you want to write it in. So we got to isolate that negative 1x first. Subtract 3 from both sides. That would be the inverse operation of adding 3. Last step would be divide by negative 1. A negative divided by negative is positive, so x equals positive 14. If you want to check that, you could plug it back in, and that does, in fact, check out. Okay? So last one here before you do try two on your own. So we have 7 minus 5x equals negative 43. So we got to isolate this negative 5x. Got to look to the left to see 5 sign. That's the term that has our variable in it. So this is actually a positive 7 here. We don't see the plus because it's the first term. So we actually will subtract 7. That would be the inverse operation there. So we have negative 5x. Negative 43 minus 7 is a negative 50. Okay. If you need to there, you can add the opposite. So you could add the opposite. Okay. Or when you have two negatives on the same side like that, just add them up and keep that sign. Okay, last step is to divide by negative 5. X equals positive 10. Let's check it. 10 times negative 5 is negative 50. 7 minus 50 is negative 43, so it does check out. Awesome. Okay, so here's two problems, two-step equations. Go ahead and try these on your own. So copy them down on a separate sheet of paper, and hopefully you are copying all the examples down. That's the way you're going to learn more effectively, is by copying all the examples and doing them along with me. So copy down these two problems, solve them on your own, and we'll go over them. So the next 25 seconds will be blank. Okay, So hopefully you got a chance to try these on your own. So for the first one, we have to get the negative 7x by itself. So we subtract 2. And by the way, if my pace is ever too fast, just stop the video, okay, and go back. So we have negative 7x. This is like adding two negatives equals negative 7. Last step is to divide by negative 7, and x equals positive 1. If we plug that back in, 1 times negative 7 is negative 7. Negative 7 plus 2 is negative 5, so we're right. Let's look at the next one. So we have negative 9 equals 3 plus 4x. Try to move this out of the way here. There we go. So I think I said 3 plus 4, excuse me. 3 plus x divided by 4 in the second equation. But we do have to get that x divided by 4 by itself first, right? That's the term that has our variable in it. So we want to subtract 3 from both sides. Very similar to the last problem, negative 9 minus 3 is negative 12. Bring down our x over 4. And now in order to get x totally by itself, it's being divided by 4, so we would multiply both sides by 4. So we multiply both sides by 4. Negative 4 times 4 times a negative 12 would be negative 48. So negative 48 equals x. If we plug that back in, let's try it out. Well, negative 48 divided by 4 would be negative 12, right? And then 3 plus negative 12 is negative 9, so it does check out. You could always check your answer by plugging the value back in for the variable and using order of operations. So hopefully you found this video lesson helpful on two-step equations. If you have any questions at all, please feel free to ask me in class or send me an email, and I'd be happy to answer your question. There's also a plethora of resources online. So if you're struggling at all you got to do is search solving two-step equations on any credible math website or resource, and you should be able to find a lot of different resources to help you. Thank you very much. Have a fantastic day, everybody.